Alright, in today's lesson we're going to go ahead and be doing part 2 of our tree diagrams. These are going to be a little different. They're going to have to do with percentages. We are going to use the tree diagram to figure out all the different possibilities. So example number 1, soccer game. If you're off to soccer and love being the goalkeeper, but that depends on who the coach is today. So with Coach Sam, the probability of being goalkeeper is 0.5, which is also known as 50%. Okay. With Coach Alex, the probability of being goalkeeper is 0.3, which is equal to 30%. Sam is coached more often with a probability of 0.6, meaning it is 60% of the time. So what is the probability you will be a goalkeeper today? Okay. So our tree diagram is set up right here. Okay. And so let's put you right here. You. Okay. Now, our first one has two choices to it. Okay? We know that either Sam is the coach or Alex is the coach. And then whether they're the coaches, either one of them are the coaches, you have a chance of being the goalkeeper. So, our first part here is we're going to figure out what's the probability that Sam is the coach versus Alex is the coach. So we're going to put Sam right here. We're going to put Alex right here. Now our question says that Sam is the coach more often with a probability of 0.6 or 60%. So next to Sam here, I'm going to put 0.6. Okay? If Sam is coached 60% of the time, that means the rest of the time has to be Alex. Okay? And so those are the two coaches that'll be there the 100% of the time. So if Sam is there 60% of the time, that means Alex is there 40% of the time. And 40% of the time is 0.4. So what does the probability of Sam being coach and not being the coach add up to? That equals my 100%, which is equal to 1. 0.6 and 0.4 add up to be equal to 1. Alright, so now I go ahead to if Sam is the coach. I'm going to come up here to this statement. With Coach Sam, the probability of being goalkeeper is 0.5 or 50%. So I'm going to put a yes for goalkeeper and a no for goalkeeper. If he's the coach, you are goalkeeper 50% of the time, 0.5, which means you are not goalkeeper 50% of the time. That's for Coach Sam. Now if I go to my Coach Alex part, I have you are the goalkeeper 30% of the time. So I'm going to put another yes, no here. Like, yes, you're the goalkeeper. No, you're not. And in this case, you're a goalkeeper 30% of the time, so 0.3, which means you are not goalkeeper when Alex is there 70% of the time. Notice how 50-50 add up to be 100. 50-50 add up to be 100. 60-40 add up to be 100. Okay. So what does the probability of being goal and not being goal add up to? Again, it is 100%, which is equal to 1. Okay. Using this tree diagram right here, I'm going to go ahead and put a couple number sentences together to help me figure out how often you are the goalkeeper. So my first one is, what is the probability that Sam is the coach, you will be goalkeeper? So here's my Sam and the yes part. Okay. Sam has to be the coach and you have to be the goalkeeper. Notice how I have an and in there, which means I'm going to go ahead and multiply. 0.6 for Sam being there, and he chooses you to be goalkeeper 50% of the time, or 0.5. Multiply those together, you get 0.3. So 0.3 or 30%. Okay. Next part is, what is the probability that Alex is coach, you will be goalkeeper? Here's my percentage of Alex being coach, and yes, he's the goalkeeper, or he chooses me. So Alex coach 0.4 times, and he chooses you 0.3 times. Multiply those together, you get 0.12, 0.12, or 12%. Okay, either one. And then I come up with, what is the probability that you will be the goalie today? So now we have our Sam chooses you 30% of the time, so 0.3. And then we also have Alex chooses you 12% of the time, so 0.2. I can have Sam or Alex be your coach. When I have that or there, I go and add them together to get me 0.42, or 42% of the time. Let's go ahead and try another example. Alright. My next example is Jack wakes up late on average 3 days in every 5. It should be days up there. Okay. So if he wakes up late, the probability that he'll be late to school is 0.9 or 90%. If he wakes up on time, the probability that he'll be late for school is 0.3 or 30% of the time. Okay. And we also know that Jack wakes up late 3 days in every 5. 3 out of 5 is equal to 6 out of 10, which is equal to my 60% or 0.6. Okay, so we're going to need that to solve it. So what is the probability Jack, okay, so let's say Jack will get to school on time. Sorry. Let's put Jack here. Okay. All right, so we know that Jack wakes up late 60% of the time. So we're going to do late, not late. Okay. And if Jack wakes up late 60% of the time, that means he doesn't wake up late 40% of the time. So 0.4. Okay. And then what is the probability of Jack waking up waking up late and waking up on time need to add up to? Again, that is 100%. Okay, that 0.6 plus 0.4, or 1. So now if he wakes up late, this is this statement right here, okay, he will be late for school 0.9 or 90% of the time. Okay, so we'll do late to school. It's going to be 90% of the time, or 0.9, and we'll do another not late right here, which means 0.1. These have to equal 100% or 1. If he's not late waking up, okay, we go on to our next one here. The probability he'll be late to school is 30% of the time. So even though he wakes up on time, he's still late pretty often. And then he would be not late 70% of the time. Again, these have to equal 100% or 1. Okay. So if I go back to my question, so what is the probability Jack will get to school on time? That means we want him to be not late here. Okay? So I do he wakes up late 60% of the time, and he's not late 10% of that time. So wakes up late and is not late to school. I get an answer of 0.06. Okay. Then I go ahead and do doesn't wake up late and is not late to school. Here is my 0.4 for not waking up late, and then 0.7 for not being late to school. This gives you an answer of 0.28. Okay. So 0.06 or 6%. Oops. And then 0.28 or 28%. So I found out those percentages. Now I can take those and figure out what the probabilities will be on time. So say he wakes up late and then he's not late for school, that would be 0.06, 6% of the time. Or he cannot wake up late, which means he's not late to school that many times. We're going to add it to the 0.28. And we get an answer of 0.34 or 34%. So he is not late to school 34% of the time, which means he's late to school 66% of the time. Okay. So I'd like you to go ahead and do now. Pause your video. I want you to try these two examples. Make sure you are writing out the tree diagrams. Make sure you're labeling them. Okay. And make sure you're writing your percentages. Remember, your percentages should add up to 100%. Okay. So let's go ahead and look at our first one after you've tried them. We have Justine getting ice cream. Okay. So we know that Justine gets ice cream depends on if her mom cooks pasta or not. So we know that her mom cooks pasta 35% of the time, so we're doing pasta versus no pasta. Notice how they add up to be 100. Then we have if she cooks pasta, she gets ice cream 60% of the time. 21%. Then if she doesn't cook pasta, she gets ice cream 25% of the time. So 0.65 times 0.25, 0.1625. I'm going to go ahead and then add all these up together, 0.21 plus 1.1625, and get an answer of 37.25%. And I have Bill delivers newspapers here. Alright, it says that, let's go ahead and scan out here. Alright, so it says that Bill delivers newspaper in rain or no rain, and then he rides his bike or gets a ride in his brother's car. We figured out that it rains 30% of the time, so which means we have no rain of 70% of the time. If it rains, he rides his bike 25% of the time. So we're doing 0.35 times 0.25. If it doesn't rain, he rides his bike 85% of the time. So 0.7 times 0.85, 0.595. So I'm going to go ahead and add my two totals up to get an answer of 0.67, or 67% of the time he rides his bike. Okay. And that is solving probability with our tree diagrams, part 2.